So my name is Almiray. I work for Oracle for close to a year now. And I'm a Java champion, and I have created a community here in Switzerland called Hackergarten, which is a group of people that works on open source projects and after hours. We just come together once a month and hack on open source for a couple hours and have some pizza, have some beers, have some snacks, and just enjoy just making things better for the rest of the world. We have been very helpful. Well, we have been very lucky to have more people joining this, and we have exported the idea to a couple of other cities here in Switzerland, but also some other countries around the world. Well, with this in mind, we have to go through a little bit of history, and I would like for you to come to me back to 1995, when Java was announced to the world. Here's a little bit of trivia. Does anyone know what's the original name of Java? And I'll give you a hint. It's not Oak. If you know, just please write on the chat. If not, I will let you know at the end of the session. So when Java came about, the syntax was designed in such a way that it was very close to C and C++, just because C and C++ were the dominant languages in the market. The idea was to get most people to jump into this new language, into this new platform very easily, so that they can find things that they are familiar to them. Given that Java promised to allow you to write a program in one platform and then compile it and then run it on any other platform without any changes, we needed a tool to build projects. And when Java was announced, there was no such thing. The only thing that we had, again, based on what we used to know from C and C++, was Makefile. It's possible to have cross-platform builds with Makefile, but I mean, we're talking about more than 25 years ago. That wasn't really easy. So as projects started to grow, and people really wanted to take advantage of the language of the platform, they needed a build tool that allowed them to have multi-platform builds. And you may probably be aware of a project called Tomcat, Apache Tomcat, the first web server written in Java. And the project was so big that really needed a build tool, and that's how Apache Ant came to be. The build tool of Tomcat, and that exploded into a whole set of new projects that allowed more people to build stuff. And when Ant came out, it was inspired by Make, so that you can define all the targets, everything that you need to do in your build file, and also had something else, which is it was based on XML, because, well, the XML was the natural choice at the time to do declarative stuff. Fun fact, the creator of Ant did ask for an apology for choosing XML to define the format. But regardless of this, the advantage of that is that it really allows to build projects at a larger scale. It became so large that there were some of the people that said, well, this is unmaintainable. Our build files are just a gibberish and a jumble of XML instructions. We need something that has a shape. We need something that has a well-defined structure. We need conventions. Also, we need a way to deal with our dependencies. So there were jar files all over the place. There was no metadata to find what is inside that particular dependency or jar, what else that jar could do. And that's how Maven came to be in the early 2000s. So Maven took some of the lessons learned by Ant, and it added a few more features, such as standard project structure, which you can still deviate from if needed be. It added dependency resolution mechanism, which Ant didn't have. Eventually, Ant has something like that with a project called Ivy. And this allows us to build even larger projects. And as a matter of fact, it also allows us to build multi-project builds. And the Maven grew so big in adoption that it continues to be the dominant build tool in the market nowadays. But sometime in 2007 or so, this is when Maven was in version number 207 or 208, if I'm not mistaken. There were another bunch of people that saw Maven, and they were longing for something. That is, the Maven structure was too strict. The restrictions were too much for their testers. And they wanted a tool that will give them the freedom to bend the rules to the project needs and not the other way around. It's been said by some that is the Maven way or the highway. So these people decided to create another tool called Gradle. And the first release came out in 2008. And this about the time when I, being a member of the Groovy development team, decided to give Gradle a try. And I completely let go of Maven. Maven 3 came out 2 years later in 2010. And Maven 3 added a host of features that myself I was completely oblivious to just because I spent 10 years in Gradle land. But I think it's almost 2 years ago, I went back to Maven and had a look at some of the features that the build tool offers to figure out if there were features that are already found in Gradle that Maven has, or there are features in Maven that are really good that Gradle does not have. And that's how I came back to having a look at Maven, and that's how this particular session came to be. And what I'm going to showcase is some of the features that really make Maven shine, and most of these features can be used in a combination to make things even better. Now, again, I also expect some of you to be familiar with some of these features, and I'm pretty sure there will be a few others that will be new to you. So without any further ado, let's begin. One of the things that you can do with Maven is define project properties. And you can also override, say, properties in a couple of ways. Now, properties can be defined in some various ways. The first one is that if you have access to the POM file, then you can open a properties block and define a series of key values. The key will be the name of the property, the value will be the name of the property. There can be some type transformations, depending on whether it's a string, a number, a boolean, but very simple ones. Or properties can also be exposed by plugins. If you happen to be a plugin author, you might have seen that mojos, which are the objects that react to behavior, that provide behavior to Maven. These modules have fields, and the fields are annotated with an annotation called add parameter. And this annotation exposes, by default, the name of the field. You can change this, of course. Now, it doesn't matter how these properties are created. You can override the values on the command line using -d switch. And I'm going to show you a quick demo of this. Now, you should be seeing now the black terminal here. And I'm going to change into project. Please let me know in case there is any problems with the lag. So I have a project here whose POM file is very simple. It's trivial. As you know, every POM file has to have its group ID, group artifact, and version coordinates, or shorthand for GAP. This particular POM has also a dependency on common slang. There's nothing else to it. And I believe this contains a class, which is an executable class. And we can see it like this. It's a simple application that prints out hello world. All right. So here's the thing. I have, if I'm not mistaken, the latest version of Maven installed. And we can verify this with Maven /version. It is indeed Apache Maven 363. I am using Java 8. That's not the latest update, but it works. And I'm running on OS X. Perfect. So if I want to compile this class, I just have to do invoke Maven compile incident. Great. So this goes about and compiles the project. Fine. Now, remember that I said I'm running Java 8. So I will expect the compiled classes to also be Java 8. Isn't that the case? Well, let's see. I can say Java P minus B minus C minus X, if I'm not mistaken. Let's go into the classes. That's classes called Acme class. And now let's do the head so that we see the first 10 lines. Oh, sorry, that's probably not minus C. It's minus B. There we go. Major version 49. Does anyone know what particular version maps to? That's actually Java 5. It's not Java 8. So what's going on here? So Maven has a series of default settings that come from a concept called the Maven Super POM. And the default for Maven is to use Java 5. Now, we can override this value by providing a property, and there are many ways that we can do this. We could define the Maven compiler plugin in the POM file and a bunch of XML lines. We could define one of those properties exposed by the Maven compiler in the properties block, or we can simply try to override in the command line. Something like this. Let's do a clean so that we don't have any lingering bytecode. We do compile, and we also specify one property called Maven compiler target equals 1.8. So I want this to be Java 8. So we execute this, recompile the code, perfect. And when we had again our bytecode, turns out that major version is now 52. So this is what we expected. We were able to change the behavior of a build just by overriding a property. Here's another thing that, no, that's what I want to say about this particular demo. Let's go back to the slides. All right. So the next one, that's really something that I found really cool about Maven, is that you can execute any plugin, any goal, just by defining the group ID, artifact ID, and version, the gap coordinates for said plugin and the goal, plus any additional parameters the goal may expect. So here's, for example, if you would like to invoke the echo plugin in any project, this is what you need to do. Define the group ID, artifact ID version for that plugin, the goal in this case is echo, and define any parameters. Now that we know that we can override values for any property using the -d flag, then this will be easy. So let's look at demo of this one. Let's go back here in the command line, and I do have command. That's not what I want to do. That looks like this. So it's the execution of that command. I'm going to copy this to show that it's actually true. I'm going to say something like, hello, MelbJVM Java user group. And let's see what happens when I enter this thing. Scanning for projects is something like downloading from Central. What is downloading? It's downloading the plugin because I didn't have it on my Maven local repository. Then executes, and I can see the output, hello, MelbJVM jar. So what happens if I execute this command line again? Well, given that the plugin already resides on Maven local, then it just simply executes the thing. This is one of the advantages of Maven. We know it's dependency resolution. Now, I have another command here. I think it's this one. Say that I want to run the executable for this particular application. Well, that requires a plugin called the exec Maven plugin. The goal is Java, and I can pass I can define the main class with an argument like this. So that's an easy as just passing command 1 to shell, and we will get a running application that says something like hello world. It's also true that there is a set of plugins that are known to Maven, coming those that have a very specific group ID. I think it's org Apache Maven and also org powerhouse. It so happens that this project, this plugin org codehouse module, the exec Maven, is a well-known plugin. So I can reduce this expression to something like this: just exec, which is the short name of the plugin, plus the goal. If I do this, it should result in a similar output, just executing the plugin, and there we go. So now we know we can run any plugin on a project, and we can also pass parameters to it. All right. So then we have seen a little bit of dependency resolution, and this is one of the things that people really love about Maven, and they also hate because there are some things, there are rules that we think they're easy to understand, but for some reason they happen to be backwards or completely different to our expectations. Let me show you what I mean by this. So we know that we can define dependencies in a block called dependencies, and every dependency that we have defined here will be known as a direct dependency or an explicit dependency. And if we happen to have a hierarchy of parent POM files, and any of those parents define also dependencies in a dependencies block, they continue to be direct dependencies. When Maven resolves direct dependencies, it always chooses what is the nearest one or the closest one. And if you happen to define two different versions of the same dependency group at the artifact ID, the one that is defined latest is going to win. But when you have transitive dependencies, that is dependencies from your other dependencies, then the rules are different. It's not the nearest one, the latest one that is going to win, but it depends on where in the dependency graph this particular dependency is located. And if Maven goes to too many hubs to reach that dependency, it will figure out which one has the less number of hubs. And once it finds out which one it is, it's going to select it. And it might not be the one that you're expecting. So a few months ago, I ran a quest of Maven resolution rules. And it's a quest that has 14 questions separated in 3 sections. And I'm going to show you just 2 questions. The first one actually looks like this. You have a POM that contains 2 definitions of the Guava dependency with different number. So the question is, if I were to resolve the dependencies, and which one will be selected by Maven? Is it going to be version 27 because it's the first one that is defined? Is it going to be version 28 because it's the latest one or the last one defined in the POM file? Or is this going to be some sort of error because, well, that's clearly duplicate dependencies? So when you run this with Maven, even the latest version, which again is 3.6.3, you get something like this. So the command line is dependency colon 3. Now you may be wondering, where is this dependency thing coming? That's a plugin coming from the Apache Maven group, which means I can invoke it using the shorthand notation. This plugin is not applied by default on the super POM, but you still can invoke it. Now it tells me that there is a warning here. The POM file is not well formed. You have 2 versions for the same dependency, 27 and 28, but Maven will still allow this to run. So it's a warning, it's not a build error. And the chosen or the resolved dependency will be, ta-da, version 28, the last one. Why? Because these are 2 direct dependencies. Now I'm going to show you the second. This is the fed question on the questionnaire. I chose to now run a POM file that has transitive direct dependencies to Guava. So Juice version 4.2 depends on Guava 25, and True version 1.0 depends on Guava 27. Both of them are in the same distance from the current POM, so there's only one hop to find them. So who is going to win? Is it going to be version 25? Is it going to be version 27? Or is it going to turn into some kind of build error? Well, the answer is actually version 25. Why? Because Juice was defined first, and Maven found this one first. So let me show you a quick demo of this. You probably have seen something like this before. Let's change into another project like this. Let me show the POM file where clearly Juice is first and Truth is defined second. And I invoke dependency 3 on this project. And well, we get something, what's going on? Not plugging, typo. There we go. Maven dependency 3. And when it resolves, it says that definitely Guava 25 is the chosen version. But what if we were to invert the order? What if we were to put Truth first, Juice second? This is the other project that I have for you. This POM file has Truth first, Juice second. And if I resolve this with dependency 3, then the chosen version of Guava happens to be 27, again, because it is a transitive dependency. And now you may be wondering, what's going on here, Andres? That's not what I expected. Regardless of the location, regardless of Juice or Truth being first or second, version 27 is clearly bigger in terms of semantic versioning to version 25. I would have expected Maven to have chosen version 27 regardless. What's going on here? Well, Robert Schulte is the Apache Maven PMC chair, so he is the one that oversees the whole project. He is one of the many volunteer developers working on Maven, and he has something to say about how Maven resolves dependencies. Maven never looks at the version number. It never did. It only looks at the location of dependency in the tree, and the closest one is the one that is chosen. And this decision was made many, many years ago. This was even before Maven 3. And given the size of projects and how prevalent the semantic version is nowadays, it wasn't when Maven was first designed and it was released. It might be the case that they need to re-evaluate this, perhaps in Maven 4. We'll see. How can we fix this? Is there a way that we can tell Maven that you want a particular version of Guava to be chosen regardless of its location in the graph? Yes, we can. There is this block called dependency management. So dependency management works like a lookup table, if you will. Given a group ID and an artifact ID, if there is a match anywhere in the dependency graph, then the chosen version is going to be the one that you had defined in that particular block. So if Guava is found one hop away, or 5, or 10, or 100, it doesn't matter. As long as that group ID and artifact match, then the chosen version is going to be the one that you defined it. So if I go back to the terminal, I believe I have a version of that. I think it's Project Transitive 3. And let's look here. Just to make things different and interesting, in my dependency management block, I actually have a different version of Guava, Guava 29, which is different from what truth and juice expect. If I attempt to resolve dependencies here, then the chosen version happens to be 29, even if truth was first. And if I were to invert this, if I put juice first and truth second, even with the dependency management block, the chosen version of Guava will continue to be 29. That is the promise of the dependency management block. All right. If this is not enough, then you can also use a project called or plugin called the Maven Enforcer plugin, which one of the things that I like about this is known as the loving iron fist of Maven, because given the rules that you configure for this plugin, you will fail the build more often than not, and this is something that you want. One of the rules that you can have in Enforcer is called require upper bounds. This will give you the resolution based on semantic versioning. There is another one called dependency convergence, which means that if you happen to have two different versions of the same dependency somewhere in your graph, then the build will fail and tell you, something's wrong. Perhaps you need to exclude, perhaps you need to fix a version using dependency management or the required upper bound. So some other rule. The point is that having different versions of the same dependency is not a good idea. And there are a bunch of other rules here that you can apply. I also asked about the same time who uses the Enforcer plugin. Now, of course, the sample size is not really that big, it's just 386 votes. But as you can see, even those that are very active on the Twitter sphere and know Maven do not use the Enforcer plugin as often as they should. So if you have not used the Enforcer before, I really recommend you to have a look at the Enforcer plugin and the things that it can do. If you're curious about the quiz, here is the link to the results of all the 14 questions. This graph showcases how many people got correct answers, and you can see that out of 509 people, only 7 people got 14 answers correct. That was very surprising, and not even myself, I got the 14 correct answers when I was building this quiz, and that was quite a learning experience. We have 3 sections. The first section is just a simple POM file with 6 questions. And the second section is where we add a parent POM file into the mix. And the third section is when we add a BOM file or a bill of materials. Now, you might remember that I showed you questions 1 and 5. And these ones, the ones that have really low correct answers. Because for some reason, people got confused and they thought that even 35% of the people thought that the build error answer was the correct one. Here you can see how many people chose across the different answers. if build error happened to be a valid option. Turns out that they designed the quiz in such a way that the build error was never an option. It's surprising to see 35% of answers saying when you have duplicate dependencies, there has to be a build error. So what's going on here? Well, I think that most people were either using the Enforcer plugin or they have support from the IDEs to flag duplicate dependencies. So it happens that only NetBeans and IntelliJ gives you proper flagging of these issues. VS Code and Eclipse does not. If you have some problems with class path dependency, I certainly encourage you to have a look at this presentation by Robert and from Ray, another Java champion. The link here points to the slides and the video of the many times that these two gentlemen have shown what can happen, what can go wrong in a Maven project, and how you can fix these particular problems. If you have any questions, please let me know on the chat. So next, we're going to jump into another thing that is very, very common, and I myself used to do this a lot of the times. What is the first thing that you do when you build a Maven project for the first time? What is the most common instruction that you find on a README file or in Confluence or something else on a wiki page when someone tells you you should build this project? That's right. Maven clean install, isn't it? Well, I'm here to tell you that invoking Maven clean install all the time might not be in your best interest. Because it so happens that the first rule of Maven clone is you do not invoke Maven clean install. No, seriously, the second rule of Maven Club is you do not invoke Maven clean install, because what you actually want to do is invoke Maven verify. If you do not like Tyler Durden telling you this, well, allow me to tell you this in a different setting. You should invoke Maven verify. That gives you rainbows in your build. What's going on here? Maven verify was one of those features coming from Maven 3. Back in the day of Maven 2, there was no incremental build support baked into the core build tool, which meant that we had to invoke clean install all the time, because you can resolve dependencies only from a repository, or so that's what we have been told. When you invoke install, you actually invoke a lifecycle phase where plugins such as the install plugin will hook into and invoke whatever needs to be done. In this case, is copying the resolve artifacts from your specific build into Maven local repository. So that means you're working with files that's I/O, as I/O can be slow. If you do not need to resolve artifacts from a repository, that means your build's a little bit faster. And that's exactly what verify does. Verify is aware of everything that your build has done up to that point and expose the artifacts to the rest of the build so that they can be resolved when needed. You do not need to copy said artifacts into a repository. Also, if you were to invoke clean all the time, every intermediate computations, artifacts, classes, process resources, all those things will disappear. And that means you pay the price of computing those results over and over again. If the plugins that you invoke, the goals that are invoked in your build are aware of incremental build and they can take advantage of the incremental build features, then your build will be faster. This is something that Robert showcases in another session at Devox 2019, where he shows some of the historical reasons between Maven 2 and Maven 3, and clean install and verify is one of those. Here's another nice feature that this one actually is coming from Gradle. I think, sorry, there is a question somewhere. I heard a ping. Oh, that's a different thing. Let's go back to the slides. Sorry about that. So one thing that I like in Gradle is that you can invoke, let's say, a goal. Actually, in Gradle, things are called tasks, but pretty much the same thing. You can invoke a goal on any project And when you invoke that code, it will figure out where all the dependencies in terms of jars or in terms of other tasks goes need to be invoked. You can do something like that in Maven using the -am and -pl flags. Let's call this partial execution. I don't know if this is the official name. But when you're building a multi-project build, and I expect most of you to have encountered a build like this at least once already in your developer career, every time that you run a multi-project build, there's something called a reactor. A reactor is the entity that understands how the different relationships within the projects work inside a single multi-project build. Now, I don't know why the name reactor came to be, but I do know that the reactor did not exist in core when Maven 2 came out. Because you might remember the time, then this is close to 15 years ago, the multi-project builds were not one of these features that came into core. There was a third-party project called the Reactor Maven plugin that gave us these features. It was so good that this feature was later added into Maven core, and the name reactor stuck. Anyway, when you invoke a reactor, every goal in the reactor is going to be executed for every single project that belongs to the reactor. You can invoke a subset of the reactor by defining the -pl flag, and you pass a path or paths to this flag to tell it what are the projects that you want to include. And you also invoke, if you need additional dependencies, say you have a sibling project that needs to be built, then you pass the -am that stands for also make. So PL stands for project list and AM stands for also make. So let me show you a demo of this. Let's change into this other project called Apache 1. And let's see. I have a sub-project here because it's a root project called here POM file and 4 projects, 1 to 4, each one of them with a source file. If I see the root file, here it's called the gap sets is built, and it contains 4 submodules, 1, 2, 3, 4. That's good. If I see, look at the first one, so that's project 1, hold on a second, POM. It's a simple project. It defines the coordinates to its parent and then the artifact ID, nothing more. Project 2, I believe, has a dependency on 1. So it has a dependency on a sibling. Project 3, I believe, depends on 2. That's correct. So it depends on a sibling to be built. And project 4, I believe, is like 1. It has no dependencies. So when I invoke, in this case, let's do a clean, just make sure that I don't have anything that is lingering, nothing up my sleeves. And I do compile. Remember, these goals are going to be invoked for every single project in the reactor. So the reactor at the beginning says a summary. These are all the projects I'm going to build in which particular order. Then it goes about and runs everything that needs to be invoked, and then the summary. Good. So what if I only want to build project 2? Well, let's begin just by building project 1. Let's do a clean here. So nothing there. Good. Now let's do Maven-PL project 1. Can I build this? Oh, I didn't specify anything. That's my mistake. Let's do compile. There we go. Yeah, I can build project 1. That's pretty good. Actually, if I follow my own advice, I can do verify, and we can see that verify will compile, and it will run, compile the sources, compile sources, resources, compile the tests. I tend to run the tests, but I didn't have anything. I build a jar, but it does not push to my Maven local because I didn't install. So if I want to just make sure that my project builds, just invoke and verify is good enough. Let's see if we can do the same thing for project 2. Remember that 2 depends on 1. And nope, can't build. Why? Because it cannot find project 1 dependency, which should be on a some repository. And this is the reason why we often call clean install. But let me tell you that even with verify, The only thing that I need to do here is add that flag, -am, and this will work. And here is how it does. Again, because Diane says I'm going to build also my dependent. So I can see in the reactor, that is the root, project 1, and project 2. How cool is that? And I invoke verify, and if I look into my local repository, you will not see project 1 or project 2 in that repository. If I'm not mistaken, project 3 contains an executable class of com-acme main. And so we know that we can invoke goals like this, right? And we know that we can also define values for arguments like this. So that would be main class com-acme main. Isn't? So what we want is to build project 3 and execute that particular class. Let's see what happens. We got a failure. What's going on? So the reactor is actually correct. The root, project 1, 2, and 3 because of dependencies. But then it says something silly like this. We're building the root, and it tries to resolve com-acme main on the root. And we get a failure. What's going on here? Well, this is one of those catches. Because you might remember that I said every goal that we invoke on the reactor is invoked for every single project. That means exec.java was invoked or was supposed to be invoked for every single project in my reactor. But only project 3 reacts positively to it. The other will not. So these are some of the restrictions that happen with this. Because every plugin and every goal is invoked for the same, for all the projects in the reactor, and we have to do something. What we have to do to work around this for now is that we have to be sure that the plugin that we want to invoke is defined in every single project. For this, we use the plugin management block. We may have to define some dummy values for some parameters just to make sure that when the reactor constructs what needs to be evaluated, works correctly, but that does not mean it's going to be executed. So let me show you a demo of this. I believe I have another project here. It's called Apache 2 when we have everything set up. So this project looks exactly like the other one. 4 projects, 1 root, 4 sources, but the root file looks differently now. The root file now, besides the 4 modules that we saw earlier, defines the following. 2 properties using the properties block. These properties are exposed by the exec plugin, the skip, so that we always ignore execution of the exec plugin, and some gibberish value for the main class. In the plugin management block, we define the particular version of the exec Maven plugin that we want to use, or any other configuration. In this case, there's nothing else that needs to be done. And we also apply the exec Maven plugin. This means that every single project in our multi-project build is going to have this. Project 1 and project 2, I believe, have the same setting. So there's nothing that has changed in 1, nothing in 2, nothing in 4 that has changed. Only project 3 has changed. And how it has done it? Well, it defines a specific value for the main class, but also in its plugins block says the skip is set to false. That means that it will inherit the settings for exec Maven plugin from its parent, but it also makes sure that the exec plugin can be invoked here. So in this project now, if I go back to the command line that I had before, I can just simply invoke exec.java. I think I have to invoke compile as well, just to be sure that I have the compilation classes and exec.java. And let's see what happens now. It works because on output 1, 2, 3, the reactor happens to be built project 1, 2, and 3 as expected. Does not include project 4. That will be the full reactor. We see that exec Maven plugin has been skipped for the root, a skip for project 1, a skip for project 2, but executed for project 3. And this is exactly what we want. All right. We have already seen something like this, aggregating POMs. So an aggregating POM is a POM file that defines a module section. That's all that is to it, nothing more. It's very common to find parent POM files that are also aggregating POM files, but they do not have to be, and this is a very key distinction. Another distinction is that the module path is not the name or the artifact ID of the project, but because it's so common to define projects in adjacent directories that the module and the name of the artifact ID match. So say you have a project like this, and I should make this example a bit better. Say there's a project called base, which is your project. There's another project called BOM, which in this case, let's say something like Apache Common Slang, and you have an aggregating POM file. So why would you like to do this? Say there is a bug in Apache Common Slang or some other dependency that you have. It happens to be open source, and you contact the team at the other side and let them know, hey, well, this bug, could you please help me out? And they will certainly do so at some point in time. But you need the fix right now. What can you do? Well, you clone the repository, you apply the fix, you push the artifact to a repository such Maven local or your organization's repository. And then you test it out, and then you find out that the fix is not yet working. So you iterate. You keep pushing intermediate artifacts into a repository until this thing is fixed. That takes time, again, because you're dealing with I/O, or you might even dealing with network. There is a faster way. What if Common Slang were be part of your multi-project build? Then, just by invoking verify at the top of your build, you will be building Common Slang with the fix and your own project and your own test cases. This will give you a much faster iteration cycle. And this is exactly what the aggregating POM files will allow you to do. So here, let me show you this other example. I think it's called BOM here. We have something that looks like this. We can do a clean. So the target BOM file here, this is an aggregating BOM. It just can't have any coordinates. It is whatever it is, and it has two modules, BOM and base. If I show you what base is, in this case, it consumes the BOM property. I mean, the BOM dependency. It could be done anything else. And this BOM is not published to Maven local. And then the BOM file here looks like this. It's just some BOM file. So if I jump into the base directory and attempt to build this, let's say verify, it's very likely to fail because the dependency I'm looking for does not exist. If I jump into the BOM file and do a verify, this project is working, doesn't do anything. If I jump into the aggregating directory and do a verify, see what happens now. The BOM is built, and the base is built, and everything is working. And this is the advantage of using aggregating POM files without them having to always be parent POM files. Now, we have already seen something similar already. BOM files stands for Bill of Materials. A Bill of Materials POM is just like any other POM. It contains a specific block, which I've seen already, called the Dependency Management. And in this block, we define a set of dependencies, as many as needed, that are supposed to belong together for whatever reason. So you may have, if you're using a Spring or Quarkus or Micronaut, Heliton, Jackson, so many of the dependencies, Netty, they also expose the dependency set through BOM files. Now, this particular BOM that I'm showing is a little bit silly because it only has a single dependency, but imagine that it has more than that. So one thing is to define a BOM. This is how you produce the BOM. Notice that the packaging is of type POM. It's not the default jar. And when we consume the POM, when we do it in this way, in our consumer, we have to define a dependency management block. Inside the dependencies, we define the coordinates for the BOM file, but we have to have two additional elements, and these are very important. First, look at the type. The type has to be POM. By default, Maven will assume that the type is jar. There is no jar associated with our POM artifact, so that means we have to set this. If we don't, then Maven will not find what it needs to be found. We also need to define the scope import. There are 6 scopes in Maven: compile, runtime, test, system, provided, and import. But you never heard me say system. It does not exist. It's something that the Maven team is trying to phase out. So in this case, we have to use import. And what is going to happen is that Maven downloads the BOM file. It looks at the dependency management block found in the BOM file, and it copies all those defined definitions and puts them into, or actually imports them into the consumer as if those definitions were defined or were written into your consumer. And because we know what happens with the dependency management block, that means that anything that is defined there in that BOM file will be part of the lookup table. As long as there is a match for the group ID and artifact ID, then the version number is going to be the one that has it chosen there. Now, you must be very very careful with the order of imports in your BOM file. If there happens to be 2 definitions that match the same group ID and artifact ID, but different versions, the order in which the BOM file was imported will decide which one is going to be. In this case, it's going to be the last one. So now that we have imported something here, I can just simply define the group ID and the artifact ID, and the version number will be provided by the dependency management block. And that's pretty much it. So we can combine all these features together, and makes our builds a bit faster, slimmer, with less or more XML as needed. There are a few more features that can be found in Maven 3, but what is important is that there are some usages of Maven that that we have been following since the old days in Maven 2 that are not necessarily needed now in Maven 3. Case in point, Maven cleanstall versus Maven verify. There are a series of blog files out there, or blog posts out there that can tell you more about Maven. The first link is something I have started on the Oracle blogs about how to get started with Maven, and this is still an ongoing series. The second one is from a fellow Java champion, Chandra Guntu. He goes a little bit deeper in some other areas of Maven, and I think there are now 9 posts on this particular series, is still ongoing as well. And if you happen to be using Gradle and you are longing for some of these features, then the Cord and Gradle plugins give you Maven features that are missing in Gradle. As mentioned earlier, that I'm an Oracle employee, so this is how I can prove that I'm an Oracle employee. Safe harbor statements: if you make any purchases or anything related to Oracle, don't believe anything that I said, but don't trust me about Maven. So with this, this is everything that I have for you from terms of slides. If you have any questions, I'll be very happy to take them. Okay, stop the presentation and let's see. How are we doing?